I am Abhrojit and I will be explaining question number 1 in this short video. So the first question was to find out the constant b. So we know for a geometric series the summation is p by 1 minus b if p is less than 1. So the probability mass function was like this, summation of b into k into p of k minus p to the power k minus 1. So b is a constant, we take this constant out of the summation part and we get the summation k into p to the k minus 1. So as this is a probability mass function, its summation should be 1, that we have written here. So now the tricky part is to get the summation of this part, k into p to the k minus 1. So how do we calculate that? This is very simple. We observe that this is nothing but the differentiation of p to the k. So we know the summation of p to the k is p into 1 p by 1 minus p. So we differentiate both sides with respect to p and get the summation k into p to the k minus 1 equals to 1 by 1 minus p whole square. So we put this value in this equation and get the value of b equals to 1 minus p whole square. Now we calculate the expectation of x. So expectation of x is nothing but k into probability of k. So probability of k is the probability mass function, b into k into p to the power k minus 1. So b is a constant, we again take this out. So now the tricky part is to calculate the summation of k square into p to the k minus 1. So but from 1 we know that summation of k into p to the power k minus 1 is 1 by 1 minus p whole square. So this k square into p to the power k minus 1, we observe that is nothing but the differentiation of k into p power of k. This part is nothing but the differentiation of k into p power of k. So we know that the summation of k into p power of k minus 1 equals to 1 by 1 minus p whole square. So we multiply both sides by p and get k into p power of k equals to this term. So as we know that if we differentiate k into p power of k, we will be getting this value. Differentiating this with respect to p gives us this value. So we just differentiate both sides with respect to p and get the value of summation k square into p power of k minus 1 equals to 1 plus p by 1 minus p whole cube. Then again we put the value here and put the value of b as 1 minus p whole square, and we find out that the expectation of x is 1 plus p by 1 minus p. Now again in the c part we calculate the expectation of x square. We proceed by same technique. We can take b out of the equation, out of the summation part, and the tricky part is to calculate the k cube into p power of k minus 1, but this is nothing but differentiation of k square into p power of k, and we have already know the value of k square into p power of k minus 1 as 1 plus p by 1 minus p whole cube. So we multiply both sides by p and then again differentiate with respect to p and get the value of 1 plus 4p plus p square by 1 minus p to the power 4. So expectation of x square after putting all the values we get as 1 plus 4p plus p square by 1 minus p whole square. Now again we calculate the expectation of x square minus expectation of x whole square. Just putting the values we get the value as 2p by 1 minus p whole square.